Welcome back, guys. For this rivers section, we're going to focus on the landforms that you find in the middle course and lower course of a river. So we're going to focus on meanders first of all, and oxbow lakes, and then we're going to move towards estuaries, and we'll talk a little bit about levees and floodplains as well. So they're all the different landforms that you need to know. And again, you could get asked about any of these. You might have to draw a picture. You might just have to explain it on written lines. So you need to be able to do both. Okay, some keywords that you need to know, guys. You need to know this idea of lateral erosion, where vertical erosion was the main process in the upper course. Lateral erosion, which is side-to-side erosion, is more prevalent in the middle course. You already know about the different types of erosion, so just remind yourself of those as well. Deposition is a posh word for dropping, so it begins with the same letter. If you deposit money into a bank, you're dropping money into a bank. And this happens whenever water loses energy. Then I'll show you what a slip-off slope and a river cliff look like in just a second. So here they are. So this is a typical meander. So these are some characteristics. You've got your inner bend here. Okay, so I think it's like the inner lane of like a motorway or something like that. And here you've got your slip-off slope, and this is your outer bend. If I look at a different meander, this would be the outer bend, and this would be the inner bend. You need to know that the flow is slower on the inner bend here, and that's because there's less energy and there's friction here as well, so it starts to deposit its sediment and create a slip-off slope, and it's much faster on the outer bend, and that's because of something called centrifugal force. Now, if you imagine I've got a piece of string with like a tennis ball, and I just started spinning it slowly and then quicker and then quicker and quicker, the ball moves to the outside. That force is called centrifugal force. Also, if you was in a racing car speeding round a track and you could not brake, then you would automatically go around the outside. And that force is called centrifugal force, and it's why the water is flowing fastest on the outer bend. Okay, so as it comes round here, we call it the thalweg as well. There's another posh word for the fastest flow of water. It's these keywords, guys, that are going to help you really get big marks. So thalweg, centrifugal force, it's really going to boost your grade. Okay, let's start, and that's going to create what we call a river cliff here. So let's start talking about the cross section of a meander. So when you actually were to stand into a meander and look down it, this would be our outer bend. So this is our river cliff where that fastest flow, that thalweg, is happening. And this is where we had that slip-off slope on that inner bend. You might have to draw that, or you might have to label it. You might just need to know what features are kind of where. So fast flow here where it's deeper, slower flow here where there's friction with that slip-off slope, and it's going to therefore deposit its sediment. Okay, so what actually happens here? We have a slight bend in a river, and because of that centrifugal force, the fastest flow will go to the outside, that thalweg, and because it's going to the outside and it's faster, it's going to start eroding laterally, okay, cutting into that riverbank, and it's going to form a river cliff. On the other side, on the inner bend, it's much slower, and that's going to lead to deposition. So any sediment that the river's carrying through suspension or saltation or solution, it gets getting dropped on that inner bend, and that starts to create a slip-off slope. Okay, and if this process keeps happening, then the bend's just going to get wider. So erosion on the outer, deposition on the inner, and that's going to repeat, okay, and that bend will just get wider and wider in shape. And what happens here is this just migrates across the sort of valley floor, and whilst it keeps on moving over years and years and years, so erosion, deposition, the whole thing just moves across the valley floor and it flattens it. That's actually how we end up getting a floodplain, because of that lateral erosion of that migrating river across the valley floor. Okay, so you can see it here. This is our really sort of pronounced meander here, okay? And now we can start to see that other landforms are starting to form. So this is called an oxbow lake. And you can already see here, can't you, what's going to happen? This river is going to take the easiest path. It's going to push through here, and it's going to lead to this meander shape. So let's go into that in a bit more detail. So same sort of words as before, lateral erosion, deposition, but this idea of a neck as well, which is the narrow bit between two parts of a meander. So this bit right here is called the meander neck, okay? And there's another neck in here. So that's a key term you need to know about. That neck is the narrow part between the two meanders. There's one meander here, there's one meander there. We know that's going to cut through and join, okay? We can see it happening. Okay, so this is all what happens. This is exactly what happens. We have our fastest flow, our thalweg on the outer bend. So it's happening here, it's going to be happening there, creating river cliffs. We're going to have that lateral erosion. Again, we need to mention a process like hydraulic action or abrasion, and we must explain that. So we might say the river picks up material, it moves around the outer bend of a meander due to centrifugal force. This creates lateral erosion, which makes a river cliff. And there'll be erosional process such as abrasion, where the river picks up material and scrapes away at the outer bend. This happens on the other side as well, and so the neck between the two meanders gets narrower and narrower, and eventually, usually at times of flood, key term there, flood, the river will push through the meander. Okay, now this bit's important. Because the water's pushing through this river now and created a new river channel, there's very slow water moving around here. Very slow. And remember, if it's slow, there's going to be deposition. So sediment will start to build up here. Fast forward, the sediment's completely built up here. So you've got a brand new river channel, and then you've got the old meander here, which is called an oxbow lake. And eventually that's going to dry up and leave behind a meander scar. Now, I don't think we can see any in these pictures. I'll just go back quickly to the first picture as well. So you can kind of see here, if you look really carefully, where it's kind of dried up. There's a little bit of water left in this one, but this is what you would call like a meander scar that's been left behind, okay? An old oxbow lake. So that's the formation of meanders and oxbow lakes. Let's talk about floodplains and levees. So we've already talked about how a floodplain is created due to that lateral erosion of that migrating river. For a levee to form, and these are our levees here, we need this to happen. So we need a flood. Okay, in fact, I won't even get that, looks too complicated. Let's just break it right down. This river eventually is going to burst its banks every now and again. And as it does, any sediment, and here's a posh word for you, alluvium, any sediment that it's carrying through suspension or solution, it gets dropped on the riverbanks. Okay, and that's what you can see that's happened here. But this obviously takes a lot of time, a lot of different floods. The heaviest load, the real coarse material, gets dropped first, okay? And any lighter material gets carried a bit further away. So you tend to see this kind of shape forming. Not just a steep bit at the start, but kind of like a lower bit down here as well. So to recap, flood, okay, deposits the heaviest material first on the sides of the river, on the riverbanks, and any fine sediments gets deposited further and further away. And therefore, we are left with these sort of build-up of sediment, and these are called levees. Now, these are great in one way because they act as a natural flood defense, almost like an embankment or like a river wall. However, if it does burst its banks in the future, the water now can't get back into the river. So levees actually are responsible for big flooding. They can stop flooding initially, but if a flood then does happen, they can contribute to more serious flooding. And finally, we're left with estuaries, okay? So estuaries are all about deposition. So all that sediment is being carried down the river right from the upper course, the middle course, and now we're in the lower course. What happens as it hits the sea, okay? The river water hits the sea at the mouth, and as it does, it's like hitting a wall. It's just going to drop what it's carrying. If I was carrying bricks or weights right now, and I just crashed into a wall, I'm going to drop what I'm carrying because I'm going to really quickly, I'm going to lose my energy. That's the key phrase. Okay, so it does say here you might get some erosion coming up the river from the sea as well, widening the river mouth. But at low tide, when there's less energy coming through and the river water's carrying that sediment, it hits that wall and it starts to deposit what it's carrying. Okay, now and again, if there's more deposition than erosion happening, you will get some of this sediment being deposited sort of into the sea. Okay, so you've got more deposition than erosion occurring, and then you're going to end up with this idea of a delta. So it's a little bit different to an estuary in that you've got this sediment that's being formed out into the sea. Okay, and these tiny kind of almost like little streams that are pushing through to get to the sea, they're called distributaries. A bit like a tributary that happens earlier on in the river. These are called distributaries. Okay, I believe that is everything. I hope that's been useful. I'll see you next lesson where we're going to start talking about flooding and hydrographs and some quite complicated stuff there.